Understanding the Big Bang Theory and the formation of the solar system not only deepens our appreciation of the vast cosmos, but also sheds light on the origins of our own planets and its place in the universe. It underscores the interconnectedness of all celestial bodies and the fascinating interplay of physical laws and cosmic phenomena that have shaped our existence. Earth's birth and differentiation. Timeline of formatting and layering. The story of Earth's formation and differentiation into its distinct layers is a remarkable journey that unfolds over billions of years. That's another estimate, right? Understanding this timeline and the intricate processes involved in shaping our planet is key to appreciating the complexity of the world we call home. Formation of Earth, 4.6 billion years. The formation of Earth began with the solar nebula, a cloud of gas and dust left over from the formation of the sun. Dust particles collided and stuck together, forming ever larger aggregates. These aggregates eventually grew into planetesimals, which were the building blocks of planets. 4.5 billion years ago, Earth was born through the accretion of these planetesimals. During this time, our planet was a hot molten mass as a result of the energy generated by numerous impacts and gravitational compression. 4.4 billion years ago, Earth's surface cooled and solidified, forming a thin crust. This marked the beginning of the Hadean Eon, a period, or era, of intense bombardment by asteroids and comets. They're constantly hitting it. Okay, so we're going back to the ancient Aramaic here, which, we're in the wrong page, okay, which will show that, okay, Son of God, or as you know, God incarnate, Jesus the Messiah, Jesus the Christ, creates it all. Yeah, and it says here the earth was for him, etc., and darkness was over the face of infinite space. Okay, the universe, right? There was no time as such, and the Spirit of God was over the layers of the water. So it's not really going deep and saying the same thing as what we looked at. Where is it gone? What we saw, where did it go? Okay, here, what we read here. Okay, but it is giving us the hint. I guess we take it again. Okay, through this word here, euma, eon. It all happened in a measurable period, age, or day. Okay, that strange day, right? Not a literal day, like Monday or Tuesday at 5 o'clock or 6 o'clock, as we know it, right? It's a different day. That's what it has a capital D. Okay? Very, very different day. But here it's saying nobody was around to know exactly when it was all done. Again, the example, well, God got up on Tuesday and decided, I'll create, and got up about 9 o'clock, created it all in one day, or over a series of days, 6 days, all right, and then each time went to bed about 8 o'clock at night, all that sort of stuff, right? So it's an unfathomable, immeasurable period. It took us time, okay, as these others here say, it could have been 4.5 billion years or whatever, okay, could have been sitting there for that long. Who knows? We don't know. This is just a scientific, geological science theory, right? That they'll probably will say is established fact, evidence has proven itself evident, and so forth. It's all true. It's all true. Okay, so back to this article. The two match in that way. Comparative. Differentiation into layers. Here's core formation. 4.4 billion years ago, as Earth's interior continued to heat up due to radioactive decay and residual heat from its formation, heavy metallic elements like iron and nickel sand toward the center. This process led to the formation of Earth's metallic core, which is divided into an inner solid core and outer liquid core. The heat generated by the core is responsible for the generation of Earth's magnetic field. Mantle formation 4.4 to 3.35 billion years ago. Above the core, etc., etc. Crust formation 4.4, 2.5 billion years ago. The process of Earth's differentiation into these layers was a dynamic and gradual one driven by differences in density and composition of various materials. This layering not only defines the planet's internal structure but also plays a crucial role in shaping its geological and geophysical process. Understanding the timelines of Earth's formation and the differentiation of its layers provides insight into the planet's long and complex history. It helps us appreciate how Earth's unique characteristics, including its magnetic field, geological activity, and diverse surface features, have been shaped by these ancient processes, ultimately creating the habitable world we know today. Earth's chemical composition, elements and compounds. Here's all these facts, these established facts, the evidence apparently. And here's more information here. Elements and compounds found on Earth. These are probably to do with the periodic table. Interestingly enough, what's his name? Terence Howard talks about Walter Russell, how he had this original periodic table, or he made a better one or something like that, but maybe it's been lost in time, or it's been withheld or something like that. Yeah, all those different things according to him. And he says, he mentions all about these: silicon, oxygen, etc., etc. We aren't going to go into detail because we don't want to mess it up. But if you watch this video, then he's talking with Joe Rogan, and you know a bit about this, well, you can make a comparison. Is he right on the button, or is he full of crap? Okay, we can't do that for you. You have to do it yourself. Role of volatiles and refractories, all this sort of stuff. Impact of meteorites and bombardment, heavy bombardment effects on Earth's surface and formation of the moon giant. Impact hypothesis. Probably some meteorite, is what we read, watched ages ago, that maybe a giant meteorite hurled through the universe and hit the Earth and caused earthquakes, molten lava to flow, made the ice caps melt, flooded the entire Earth and killed off all the dinosaurs, all life, etc., etc., according to the scientists and their theories, turned facts, evidence, etc. Whereas the biblical side of it is there was a great flood because man was wicked, the whole world was wicked with this sort of stuff. So God said, well, I regret making them, so I'm going to destroy them all and we'll start again. Okay, with this sort of stuff. Very different, right? Whereas the book we have, The Timetables of History by Bernard Gruen, where did it go? Says something completely different on page 3, column B or column G or something like that, that there was disastrous floods in the Mesopotamian region. And we remember coming across something that Victor N. Alexander had shared in his translation project, the same thing. Okay, well, him being from Mesopotamia, doing the history, he would know, wouldn't he? Okay, we can't find this book at the moment. We don't know what we did with it. But yeah, basically we've covered that on another video. It's here somewhere. Where did we put it? Oh, here it is. Yeah, just to again verify that we're not just making this up. This is Timetables of History, the new third revised edition, the world famous reference that tells who did what when, from 4500 BC to the present day. Well, this is actually old, real old book. It's the third revised version, revised edition. We hadn't seen any others of late. Updated for the 1990s. A horizontal linkage of people and events by Bernard Gruen, based upon Werner Stein's culture Fahrplan. It's German for some culture something plan. Okay. Not too hot on the German there. We had other pages explaining it, that maybe there was 3 or 4 people that tried to translate it and they ended up not because they died early or something like that. But this guy, Bernard Gruen, eventually did it. Something like that. Something on those lines. Okay, so we're at page 3, G, daily life, minus 4000 to 3501 BC, disastrous floods in Mesopotamian region. Okay. So we believe that that great global flood, claimed by the religious, etc., and supposedly the scriptures, was a latter. It's the latter scientific evidence of something hitting the earth, creating the earthquakes, volcanic eruptions, lava to flow, tsunamis or tidal waves, and killing off all life on the planet. Yeah, dinosaurs, etc., disappeared. Right, and then everything cooled down basically, and then everything started to come about again, okay, according to scientific evidence, etc., etc. Okay, so we're going to continue with this. Heavy bombardment period, approximately 4.1 to 3.8 billion years ago. Earth and the inner solar system experienced a period of intense and frequent meteorite impacts. This era, known as the heavy bombardment period or the late heavy bombardment, was a chaotic time for our planet's surface. It had significant implications for the early Earth and its celestial neighbours, the other planets, right? Effects of meteorite impacts on Earth's surface: crater formation, atmospheric changes, magma, oceans and geological effects, formation of early oceans, formation of the moon, giant impact hypothesis. One of the most notable consequences of the heavy bombardment period is the giant impact hypothesis. Okay, let's say guess at something, and possibly later, it's just like a theory, it becomes proven. Okay. Established fact, the evidence proves self-evident, and so forth. Okay, through these scientific studies, the research, the studies, and so forth. Okay, so one of the most notable consequences of the heavy bombardment period is the giant impact hypothesis, which suggests that the moon was formed as a result of a colossal collision between Earth and a Mars-sized body. Here's a brief overview of this hypothesis. About 4.5 million years ago, shortly after Earth's formation, a massive object, sometimes referred to as Theia, collided with Earth. This catastrophic impact was so powerful that it led to the ejection of a significant amount of material from Earth's mantle into space. The ejected material coalesced to form a disk of debris around Earth, which gradually accreted into the moon. Okay, this is what we were saying before, an earlier statement that we found it somewhere online. It probably wasn't this one, it was somewhere else. Accreted into the moon. The composition of the moon is in part a reflection of this collision with a mix of material from both Earth and Theia. Well, they say that the moon is actually a dead planet, much like the Death Star on Star Wars, right? And there's some aliens hiding in it and all this sort of stuff. Yeah, it's basically a dead planet, apparently. The composition of the moon is in part a reflection of this collision with a mix of material from both Earth and Theia. The giant impact hypothesis explains various features of the moon, such as its lack of substantial iron core which remained on Earth, its geological composition, and the similarities and differences between Earth and the moon. The formation of the moon through this giant impact not only influenced the evolution of our natural satellite, but also played a role in shaping the Earth-Moon system, including aspects of Earth's axial tilt and its gravitational influence on tides. It is a testimony to the profound impact that meteorite impacts and celestial collisions have, talking about planets, right, have had on the history and development of our planet and its cosmic surroundings. Early Earth conditions, Earth's atmosphere and composition, origin of water, and formation of continents and oceans. So this is quite similar to the biblical account. Okay. Earth's atmosphere and composition. The early Earth's atmosphere was markedly different from the one we know today. It primarily consisted of volatile compounds such as water vapor, H2O, carbon dioxide, CO2, nitrogen, N2, methane, CH4, and ammonia, NH3. Notably, there was a lack of significant amounts of free oxygen, 0.2 or O2, in the atmosphere during this period, as oxygen was primarily bound to other elements. Reducing atmosphere. The early atmosphere was considered reducing, meaning that it had a surplus of compounds with electrons that could be readily shared with other elements. This reducing environment was conducive to the formation of complex organic molecules, which are essential for the development of life. So, life probably wouldn't have happened if we didn't have those. 2. Volcanic activity. volcanic eruptions and outgassing from the Earth's interior were significant contributors to the composition of the early atmosphere. These emissions released gases like carbon dioxide, water vapor, and sulfur dioxide, influencing the planet's early climate and chemistry. Origin of water on Earth. The origin of Earth's water is a subject of ongoing scientific investigation, so they're still doing it today, investigating it, with multiple theories proposed to explain its presence. Some of the leading theories include: 1. Cometary delivery, so this water was probably inside it. It is believed that a significant portion of Earth's water was delivered by comets or water-rich asteroids during the late heavy bombardment period around 4.1 to 3.8 billion years ago. These celestial bodies contain water ice, which could have melted upon impact with Earth and contributed to the formation of the planet's early oceans. 2. Volcanic outgassing. Some water may have been released from the Earth's interior through volcanic activity. Some water may have been released from the Earth's interior through volcanic activity. Water vapor and other volatile... Let me read that again. I think we messed up there. 2. Volcanic outgassing. Some water may have been released from the Earth's interior through volcanic activity. Water vapor and other volatile compounds trapped in the Earth's mantle could have been gradually released through volcanic eruptions and then condensed to form the early oceans. 3. Hydrated minerals. Water may also have been present in the building blocks of Earth, such as hydrated minerals in the materials that form the planet. These minerals could have released water during the Earth's formation and differentiation. The exact proportion of water contributed by each of these sources is still a subject of ongoing research, but it is likely that a combination of these processes played a role in forming Earth's oceans. Formation of continents and oceans. Formation of continents and oceans. Yeah, there's a difference between continents and... What was the other? We've forgotten what it was. We had a bit of a debate with a teacher, and we said no, one has to have seas, it has to be surrounded by seas, the other one is just land, it's far from it, right? And they said no, but what kind of teacher are you? Yeah, formation of continents and oceans. The formation of continents and oceans on Earth was a dynamic and complex process that unfolded over geological timescales. Key processes involved included: 1. Crust formation. The Earth's early crust was initially composed of solidified basaltic rock. These rocks formed the foundation for the future continents and ocean basins. Continental crust formations. Over time, the Earth's crust evolved as it underwent processes like partial melting, fractional crystallization, and plate tectonics. These processes resulted in a differentiation of the crust into the lighter continental crust, rich in granite rocks. 3. Ocean formation. The depressions and low-lying areas in the Earth's crust filled with water to form the early oceans. This process was influenced by the balance between tectonic activity, erosion, and sedimentation.